An airfoil on a wind turbine blade experiences several forces and aerodynamic effects as it rotates through the air. The key forces acting on an airfoil of a wind turbine blade include lift forces, drag forces, gravitational forces, thrust and torque forces, centrifugal force, and turbulence effects, of course. Wind turbine designers and engineers carefully consider these forces and effects to maximize the energy extraction efficiency while assuring the wind turbine structural integrity. In this video, I will explain briefly lift force, drag force, thrust force, and torque forces acting on an airfoil. Let's start by overviewing a few concepts on airfoil, which is simply the cross-section of an aircraft wing or a wind turbine blade. This figure shows a horizontal axis wind turbine, and specifically its three blades. Each blade is a long, slender, airfoil-shaped structure attached to the hub of the wind turbine and extends outward from it. The blade's main role is to capture wind energy and convert it into rotational power that drives the electrical generator to produce electricity. How blades capture the kinetic energy is by the airfoil, which may have different shapes and characteristics as shown here. The design of airfoil plays a significant role in the overall efficiency and performance of a wind turbine. Let's talk about forces acting on blades. There are four forces acting on blades of a horizontal axis wind turbine. Gravitational forces that act toward the Earth's center, causing variable effects on the rotating blade. As the blade rotates, every point on it experiences a change in velocity direction. Due to the rotor rotation. This shift results in centripetal acceleration towards the blade's center, induced by the centripetal force. The drag force is caused by air molecules hitting the wind-facing blade surface. A significant part of this force acts parallel to the rotor's main shaft, as seen here in this figure. This is shaft and this is parallel. Wind passing over the blade creates pressure differences that leads creation of lift force. This force causes the blade to rotate. Now, after reminding you on a few principles, we are ready to learn forces acting on an airfoil. Wind is hitting perpendicular to the rotor sweeping plane as shown here. Now we select a cross-sectional area at a given rotational position. of one of the blades, as shown here as an example. The corresponding airfoil exposed with wind is shown here. It looks like this. We have two speeds involved here: wind speed and rotational speed of blades. In short, rotational speed at this phase of rotation is downward, and we need to first combine these speeds to find the wind that this airfoil experiences as it moves through the surrounding air. This wind is called relative wind, as shown here by W with green color arrow. The perpendicular to the relative wind represents then the lift force. Parallel to the relative wind is the drag force. Now we have again two forces. The total force is obtained by combining the drag and lift forces, as shown here by the red color coded arrow in this figure. By the projection of the total force on the rotational axis, we obtain torque force that actually causing the rotation. The component of the total force on the wind speed direction is called thrust force that causing bending of blades towards the tower.